My name is Daniel, and I've got algae-to-biodiesel, or first off, the design problem, you have three major problems in this situation. You got to harvest your algae, separate your membranes. You got to break the algae cells to get the oil out. You need to recover the oil, and then you take it to Eric's process of producing the biodiesel. My solutions for the first problems, they have continuous centrifuges. The one on your left, on top, is a solid liquid centrifuge to separate solids from liquids, so you could harvest your algae and or collect your cell membranes using such a process. On the right, top right, is a centrifugal separating for liquid-liquid for different densities and phases. So you could separate your oil from your water during a process like that. To break the algae cells, what I've been looking at is a whole lot of shear force. And they have machines that induce a whole lot of shear force in the paper industry. They use these giant plates and they have fractions of millimeters apart, and they shear whatever goes in there. So that should break your algae cells. I've got my process flow diagram here. As you can see, you put your algae into a photobioreactor, you get more algae, then you separate it from the water, you lyse your cells, you separate that to get your oil and water, then you can separate those two and send your oil to your reactor, and then you make your diesel using, I said microcatalytic reactors here, but that's still a process that has been yet to be perfected. I also have some material and energy balances. I'm not sure if you can see all that, but I started with a basis of 100,000 metric tons per year, and that breaks down to 10.7 moles per second. I went through the balances, everything seemed to balance out on my catalytic reactor, and then I did the energy streams. A little work needs to be done on those, but for the most part I've got a pretty good balance going. In conclusion, it's beneficial to the environment and to society because you can help reduce some of our reliance on fossil fuels. It can be completed this semester if you make heavy assumptions on all sorts of things, the amount of sunlight, the amount of biodiesel produced, many assumptions, and there's a potentially massive economic return concerning how much we need fuel. Any questions?